Hello, class. We're going to be teaching today about graphing rational expressions. Now, we must make sure that your graphs are accurate and complete. We must find the domain and range, and we must know what is a rational expression. Shall we begin? I don't like your attitude, young lady. Let us begin with starting graphing f of x equals x plus 3 times x minus 2 times x minus 5 squared. Let us begin, shall we? First step, we must, what? Starts with an F and rhymes with tractor. Factor. Then we must set equal to 0. So let's go ahead and do that. Oh, I cannot fit it here. Oh, I hate this job. Let's see. Okay. Now then, 0 equals x plus 3 times x minus 2 times x, that does not show up. 0 equals x plus 3 times x minus 2 times x minus 5 times x minus 5. Now, we must identify the zeros. What are my zeros? We have negative 3. Then we have positive 5. And we have positive 2. Let's label our graph. 1, 2, 3, 4, 5. 1, 2, 3, 4. Negative 5. 1, 2, 3, 4. Positive 5. I have my zeros. Negative. My zeros. Negative 3. Positive 2. And positive 5. Let's pick a number and test the limits. Let's pick a number less than negative 3. Somebody give me a number. Negative 4. Thank you, Caesar. Negative 4. Negative, 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 negative. 4 negatives is a positive. Let's pick a number between negative 3 and 2. 0. Beautiful. 0. Positive, negative, negative, negative. We have a negative. Let's pick a number between 2 and 5. 4. Or, how they say in the South, corazon. Sorry, I couldn't help that joke. Let's do 3. No, sorry, corazon. Positive, negative, negative. I have a positive. And let's do infinity. Positive, 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 positive. We must also pick a random point. Let's plug in 0. 0 plus 3 times 0 minus 2 times 0 minus 5. I'm running out of room. 0 minus 5. 3 times negative 2 times 25. Negative 6 times 25. What's 75? 150. Negative 150. which means I should change this. I should change this to 20, 50, 10, 20, 30, 40, 50, 60, 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. 0. Oh, we gotta go down. Move everything up. 20, 40, 60, 80. I must move everything up. Now, we must make sure that we increase this at negative 150. It must go all the way down there. So we scaled it at steps of 20. 20, 40, 60, 80, 100. This should be negative 100, negative 200. We have negative 150, 0, negative 150 as our point, our random point. 20, 40, 60, negative 150 will be there. We got positive, negative. Whoops. Let's do that again. Positive, negative, up here. Positive and positive. And there you go. That is our final graph. Okay, graphing rational expressions. Now, if you guys want, there is a Dewey video. But you guys don't have to watch the Dewey video. You guys want to watch the Dewey video? Okay, we'll skip it since you guys don't want to. Okay, here's the game plan. I know. Here's the game plan. Find the zeros of the numerator. Find the vertical asymptotes of the denominator. Test the limits. Then we got to find the horizontal asymptotes. Then we need to identify the points between the vertical asymptotes. The zeros in the numerator are going to be our zeros. Remember the zeros we have on the x-axis? Those are the zeros of the numerator. Anytime you have any number that makes it a 0, that means it's going to hit the x-axis. The vertical asymptotes are going to be the zeros of the denominator, right? Because we can't divide by 0. So you have those are vertical asymptotes. Now each one of those zeros, the zeros in the numerator and the zeros in the denominator, we're going to test the limits for those. So we're going to have to find out, each one. You got to see if it goes above and below for both the numerator and the denominator. Okay, so here we go. Let's go ahead and do this. Find the zeros of the numerator. What are the zeros of these numerators? Go ahead and write that out. Numerator. What are the zeros of the numerator? X equals what? Negative 4 and 2. So negative 4 and 2 are going to be our zeros that we have in the x-axis, because that's going to make them 0. All right, now, negative 4 and 2. So what are my zeros of the denominator, or the asymptotes? What can x not equal? X cannot equal what? 5 and negative 6. Okay? Those are going to be our asymptotes.
So a positive 5, we're going to go, a negative 6, we're going to go, and a negative 4, we're going to have a point, and a positive 2, we're going to have a point. And we're going to test the limits between all of those, both asymptotes and zeros. Only Chuck can divide by 0. Last time I tried to divide by 0, Nathaniel turned me in for $3.14. It's not worth it. People will sell you out. For a bag of Doritos. Is that what he said? Bag of Doritos. Here we go. Boom. So now we do the test the limits thing, right? We draw the thing. We have both the negative 6 and 5, the asymptotes, and we have the zeros, negative 4 and 2. And you test the limits the same way. Pick a number less than negative 6. Let's do negative 7. Negative 7 plus 4, negative 3. Negative 7 minus 2, negative 9. Negative 7 minus 5, negative 12. Negative 7 plus 6, negative 1. 4 negatives is a positive, right? I'm doing it fast because you guys already know what's going on here, right? Negative 5. Negative 5 plus 4 is negative 1. Negative 5 plus 2 is negative 7. Negative 5 plus 5 is negative 10. Negative 5 plus 6 is positive 1. We got 3 now. We got a negative. Let's do 0. Positive, negative, negative, positive. I got a positive. Let's do between 2 and 5. Let's do 3. 3 plus 4 is 7. 3 plus minus 2 is positive. 3 minus 5 is negative. And 3 plus 6 is positive 9. We got a negative. Then we can do 6. Positive, 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 positive. Every time we enter. Okay, so those are our limits. Got the limits. And tested the limits. Now, let's talk about horizontal asymptotes. You're going to need a whole new section for your notes on this. This is big league. Okay, this is going to be a lot of information. In my opinion, it's hard for me to gauge what you guys find difficult or easy. I think this is difficult. Hopefully I'm wrong. Anyway, the horizontal asymptotes. There are 3 possibilities. What? Or what? Those are our 3 possibilities. What? Possibility 1. Or that's possibility 2. Or possibility 3. Or Go ahead and write that down. All right, so here we go. Here's the horizontal asymptotes, 3 situations. Okay, here we go. You guys ready? Notice, before we talk about this, this is the largest exponent in the numerator. This is the largest exponent in the denominator. MN, right? Largest exponent in the numerator is M. Largest exponent in the denominator is N. Okay. If M is bigger than N, so if this is bigger than that, that means it's going to be a slanted oblique asymptote where we use synthetic division. What does that mean? That means M is bigger than N, it's going to go like this. Are you guys looking? Look at me. It's going to go like this. Slanted, or like this. Slanted. Technically, it's not horizontal, but I'm calling that horizontal. Okay? If M is equal to N, okay? This one's the most difficult one, in my opinion. This one's like medium difficult. Zoom. Okay, here we go. So M, if this is bigger than that, we got a slanted asymptote, which we're going to use synthetic division to help us to figure out what it is. You know synthetic division, you know how to graph a line. Putting them all together might be confusing. M is equal to N. If this is equal to that, what you do is you see this number here and this number here. You take the numbers in front, A and D, say this is 3 and this is 1. You divide them. What's 3 divided by 1? 3. That means that 1, 2, 3, you draw your horizontal asymptote. If this is, so I think that's pretty straightforward. If this is, say it's 10 and this is 2, right? That means that 1, 2, 3, 4, 5, anyway, that's that. This is the easiest one, in my opinion. If M is less than N, then it's just at 0. Flink, done. Same thing. Okay. So, let's try out the horizontal asymptotes. You guys ready for the horizontal asymptotes? So what do I got here? 2 and 3. M is less than N. What does that say about my horizontal asymptote? 0, right? So, blink, right at 0. There's your horizontal asymptote. Oh, I should say something about the horizontal asymptotes. Remember, okay, I'll pause. You guys are writing. Okay. M is less than N. Okay. So now let's do M is equal to N. What is my asymptote going to be? What do? Divide. 3. Uh-oh, there's no number there. What number is that? 1. What's 3 divided by 1? 3. Boom. Boom. Y equals 3. So it's going to be at 1, 2, 3. Boom. Boom. Room. Room. I meant to say boom. Okay. Now the last one's going to, in my opinion, is the most difficult, right? Because if it's smaller than larger, it's just 0. If it's equal, it's the number divided by the number. But what if the numerator is bigger than the denominator? Like, for example, 2 over 1. It's going to be a slanted asymptote. Okay, so M is greater than N. Now, it's kind of like this. If I said, what do you naturally think? I don't know if this is going to make sense to you, but if I said 10 over 2, what do you think when you see 10 over 2? What are you thinking? 5. Why? Because you can divide. 10 divided by 2. But if you see 2 over 10, right? Do you think division here is much? Because it's like the numerator is smaller than the denominator. But if the denominator is bigger and it's division, right? You think division. Well, that's what I think of here. Like, where'd you go? Like smaller, bigger, think division. So I'm thinking, right? Think division. So we have here, when you say, oh, division, Sensei, what do you mean by that? Well, let's go like this. So we have here x squared plus 3x minus 1 all over x plus 2. Whoopsie, let's make that. Why did it do that? X plus 2. You think division. All right, synthetic division, right? You guys know how to do this. 1, negative 2. 3 minus 2 is 1. Negative 2 times 2 is negative 2. Now look, I got a remainder here, okay? You guys see that remainder? Ignore the remainder, right? Let's just ignore it because it'll make our lives easier. Let's ignore the remainder. Ignore it. And remember, this was x squared plus 3x minus 1. This is now 1x plus 1. And let's write it as y equals 1x plus 1x plus 1, or y equals x plus 1. That is our slant asymptote. Do you guys remember how to graph a line? Because you got to know how to graph a line for this, right? Y equals x plus 1. So let's go over here and graph our line. We have our asymptote as y equals x plus 1, where, let us, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and ooh, I guess we got to keep this as 1, 2, 3, 4, 5. Figure that one out. And we go here. We have the plus 1 as my y-intercept, and my slope is 1 over 1. And there's our asymptote. That's your slant asymptote. That's the most difficult one, in my opinion, because you have to do synthetic division, and then you have to know how to graph. You have to remember how to go. I know you guys all know how to graph a line, but you're probably out of practice, is what I'm assuming. You're out of practice from graphing the line. Anyhow, can I move on? So anyway, those are our horizontal asymptotes. Those are the three options. So there's the synthetic division, y equals x plus 1, it'll be like that. Where are we at? Did we test the limits? Did we graph? Okay, so now let's go, I think, where are we at? Did we graph that one? Back at this problem here. Okay, here's my million-dollar question. What's my horizontal asymptote for this? What's my m and what's my n? It's factored out, but if you factored it, if you multiplied it, what would it be? What's my m and what's my n? Yes, x squared plus 4x minus 8. If I multiply that out, I'm doing it in my head. Do it on your own. X squared plus 1x minus 30. M equals n, which means we do what? Zero is m is smaller than n. If they're the same, we divide. What do I divide? No, it's the number in front of x. 1 over 1, which equals the horizontal asymptote is y cannot equal 1. There's something I need to mention about horizontal asymptotes, by the way, really quickly. Let me get back. Remember, asymptotes the line cannot cross, right? However, sometimes in horizontal asymptotes, sometimes, especially when it's equal to 0, sometimes it will cross in the middle. You can cross in the middle. It's more for like end behavior. So it could look like this. It could go like this, and it could go like this. You can have one that goes like this, right? You could have it, but in the ends, it's more like snugging it, okay? Anyhow, let's go ahead and graph that one. How are we doing? We're almost here. We're almost there. Graphing the one problem. We're only doing one problem so far, right? Haven't even finished. Where are we at? Where are we at? Okay, we have 1 over 1, right? We have our limits. Do I have it all here? Let's start over here. Have everything here. X cannot. Okay, so what are my zeros? Let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, we got our zeros again at -4, -2. So you guys, I think you guys already have that. -4, and sorry, +2. I have my asymptotes at 5 and -6. So at 5, I got an asymptote here, and at -6, I have an asymptote there. And we have the horizontal asymptote at y cannot be 1. Okay, that's pretty much everything set up, right? Should I pause? Okay. What do we know about asymptotes? Can't cross them, but you hug them. You get as close as you can, right? So that's what you're thinking here. Hugging them, hugging them, hugging them. I'm either going to hug them here, or I might hug them here, or I might hug here, right? You want to hug the asymptotes. So at -6, I got a positive here, right? So here, let me get out of the way. I have -6 over here. It's going to be positive. I have these asymptotes here. I want to hug the asymptotes. The only thing that makes logical sense, I can't go here. I can't go below it, even though it's positive, because I have to hug this one. It takes me down. So I'll take this one. I want to hug it and hug up. And there you go. There's my positive. Between -6 and -4, I got a negative. So here, I'm negative. I want to hug my asymptote, so I'm going to hug it, hug, and then get to the 0. Boom. Now, between -4 and 2, I got a positive. I don't need to cross the asymptote, so I'm not going to. You'll see what I mean when I need to cross it. There will be times when I have to. Usually it's when the asymptote is 0. So what am I going to do? Positive, hug to 0. And then from 2 to 5 is negative. You guessed it. Negative. Guess what we're going to do? Got to hug that asymptote. Looks like that. And then after 5, we got a positive. So guess what? Hug it, hug it, hug it, hug it. And that's all you've got to do. We won't worry about the random points yet, because I don't know how that will work. Plug in 0. Okay, here we go. So let's find our zeros first. What are our zeros? So we yell it out. X equals -1. What are my asymptotes? What can x not equal? 4 and -3. Set it equal to 0, factored, it's already factored. So let's go ahead and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. I have here 1 as my 0. I have here -3, 1, 2, 3 as my asymptote. I have +4 as my other asymptote. Oh my goodness. Yes, Devinalicious. And none of you caught it except for me. This should be -1. Come on. I'm just joking. Devin got that. All credit to Devin. That's you, Devinalicious. I have to recognize I made the mistake. I'm a fake teacher, even though I'm trying to look like a real teacher, which means this is going to go from here, that'd be a big difference, to -1 here. Let's go ahead and test the limits. Let's see. So here we go. I'm going to test here. From -3 on, let's do -5. -5 plus 1 is -4. -5 minus 4 is -9. -5 plus 3 is -2. 3 negatives. Oh, time out. What did we forget to do? Horizontal. Which one is it? M is greater than n, n is equal to n, or m is less than n? X to the first, x to the second, m is less than n, which means what is my horizontal asymptote? 0. Flink, 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 flink. X axis, I heard somebody say. You are so smart. So we got a negative. Okay, now let's go from -3 to -1. -2. -2 plus 1 is negative. -2 minus 4 is negative. And then we got a -2 plus 3 is +1. So 2 negatives make a positive right there. Of course, let's choose 0. 0 plus 1 is 1. 0 minus 4 is -4. 0 plus 3 is 3. 1 negative makes a negative. And then let's choose 5 or a million. Everything's positive. We got everything positive. Let's go ahead and graph it. I see you guys looking at your papers, a lot of you. I'll phone for it. Here we go. Negative. Hug it. Hug, hug, hug. Positive. Remember I said sometimes it crosses the horizontal asymptote in the middle? Well, this is the situation because we've got to hit that 0. Boom, right there, right? There's my positive, and then I got to go negative, get to the asymptote, and hug it. And then we have a positive, hug it, hug it, hug it, hug it. That's all you got to do. Okay, that's it for the lesson. We graphed rational expressions. Those of you that are running track, those of you that are playing tennis, you better watch this video. Make sure you like and subscribe. Helps me a lot. Gives me my sponsors. And I can retire as a teacher and become a YouTube star. You too!